write your answer there. Your answer there. So if you guys don't mind, just give me those numbers again for the sake of those who need them. The first one.
1, 2, 3.
1, 1, 2, 3, 2, 5. Negative 5. So you add these up, right? So you plug in the values, you substitute those values in to get you each one of those, and the answer is 4. That's how we get the answer to that problem. Okay, very good. So I'm going to clean this, since we have that one down, and we're going to go to the log problem. It's always good to know exactly what topic you're dealing with. You always want to isolate what topic am I dealing with, and then on top of that, what subtopic, right? So for example, log is a big category, right? Are we adding log? Are we simplifying log? What are we doing with log, right? In this case, we're simplifying. And so what I'm going to do is I'm going to explain the basics of log. And the basic is that if you have a log base of some sort of value, it is equal to a certain value that can make this statement true. And so this is the log, general log form, right? So in your notes, this would be good to write general log form, right? So general log form, we should make sure we have that, so that we can then see how to change it from the general log form to the exponential form, right? Your class is really graded heavily on notes. That's it. If you take good notes, you get good grades. And so basically you take this and you change it into the exponential form, which is b to the power p is equal to a. Okay, so b to the power p is equal to a. So you take the base, raise it to the power, and it equals the answer. So therefore, in this case, we basically have log base 2 of 8 is equal to some value that I don't know, and log base 8 of 2 is equal to some value I don't know, but I know the general form of the equation, which is basically changing it to the exponential. So you want to change it from the log form to the exponential form, right? That's the important part. So change it from the log form to the exponential form, and then it will allow you to work with the actual problem. This is a general form that you will see wherever you are at, or whatever you're up to. The applications of log in the history goes back to Scottish mathematician John Napier. We're not going to go into detail about him, but he was an amateur mathematician. I think people need to realize that some mathematicians were not pros like Newton. They were amateur mathematicians, and they did some amazing stuff. And they didn't have the internet, guys, right? So I should be ashamed of myself, right? At 35, I haven't come up with new calculus. You and I mean, most of them came up with it when they were your age. But anyways, as we get older, we begin to not have the ability to compute as well. That's why from age 15 to 25 is critical. Use the brain sharp during those years, because you're not going to be as good after 25 for many people. So that's why we want to bombard you with everything we can, so you use your brain to the max. At the end of Newton's life, he wasn't even a mathematician anymore. He was working in the mint. But anyway, so basically, that could be for other reasons, but I'm just saying, make the most of your years. This form here of logarithms is basically taking it from the log form, which might be tricky, like what do I do with this? Switch it to the exponential form, which makes way more sense, and then apply the formula. So according to changing this to the exponential form, remember, you look at the base, so start from the base, raise it to the power of the thing on the other side, and set it equal to the thing next to the base. So it's sort of this cycle. Take the base, raise it to the power, and equal the thing on the right next to the log. So in this case, it would be 2 to the x is equal to 8. That's what you would do. 2 to the power x will equal 8. Well, over here, you can't really do much of 2 to the x is equal to 8 until you realize that 8 is the same thing as 2 cubed. So you change it to 2 cubed, and you leave that as 2 to the x. According to laws of logarithms, if your bases are the same, your powers are the same, so x is equal to 3 on this first part. So we've justified this part. Log 2 to the 8 is 3, right? That's what we just did using the general form and the exponential form and general form. One of the things you guys realize is I keep asking people questions about them recognizing their own strengths and their own weaknesses. That is the best way to learn anything, is to know what you need to focus on and to do it well. Spoon-feeding education models is what we use in America on a big scale, and I'm saying we need to move away from it and allow people to choose, okay, I struggle with this, so I need to work on that. So I just want you to recognize that. That's really important to make sure, I need to make sure I know that. What am I struggling with? Figure out that, right? We should always go with that kind of mindset. And so in this problem that I just did over here, if there's any step along the way that you're like, I'm kind of stuck on that step, put an asterisk there so we can zoom in there, strengthen it, and then move forward. That's always important. Over here, we have the same process, right? And you can kind of walk along this journey with me. We change it from the log form to the exponential form using the general formula over here, which is take the base, right? So we circle what is that base, raise it to the power on the right side, set it equal to the number on the other side. And so this would become 8 to the power y is equal to 2. This 8 is of course the same thing as 2 cubed is equal to 2. Now keep in mind 2 by itself is the same thing as 2 to the first power. So now I can set y, 3y is equal to 1 because the base or the root, not the root, but like the foundation of this, the 2's here are the same. So the rule says you can set the 3y equal to 1. So if I set 3y is equal to 1, then y is equal to 1/3. That means this here was 3. We already found that before. This here is 1/3. We're finding that out now. So basically the problem, when it gave it to you in this format, you could just take it and say it's 3 plus 1/3. And the rest of this is history, right? We should use our basic skills for adding fractions to get our answer, which is 10/3. Here's the interesting thing about this problem though. Do you know that you can write code in this and somebody wouldn't know what you're talking about? Do you know you can write this like with log like this? Let's say I'm trying to say 10/3, but I don't want the enemy to know, and I write it in log. They wouldn't know, except they knew the laws of log. Do you see the beauty of math? You can embed messages within mathematical problems that other people don't know the answers to, except they know the mathematics to do it. One of the people that helped turn the tide in World War II was actually Alan Turing. Without his mathematical skills, I don't know where we would be. Like, without the mathematical skills of people like Alan Turing and some of these guys, we wouldn't have, I mean, they made a whole movie about him. I think it's like Code Breaker or something like that. But without having the code skills, you get in trouble militarily. Like, guys, we're giving you tools that can help you run nations, right? This is part of the tools you can use. So notice that these two things translated to a number, 10/3. I think that's pretty fascinating and a good problem from the CLEP people. Okay, next question here, number 8. So number 8 is asking you to, let's pull it up here. Let's move on to the next page. Okay, so it says, the function y is equal to x cubed minus 5x squared plus 6x plus 1 must have a root between which of the following x values. So in this particular question, in number 8, they've given you a function and they're telling you that it must have a root between which of the following x values. Now remember, the root of a function is simply where it intersects the x values. Now I can tell you for sure, this is not one of our questions on the finals. We don't want to take time trying to draw a table of values and things like that. So we're not going to use this type of question, but we are going to just talk about it briefly as far as how to get an answer to this problem. So basically, draw a table of values in your notebooks, please, starting from x is equal to -2 all the way to x is equal to 3. So let's draw a table of values. So x is equal to -2, -1, 0, 1, 2, 3. So we're going to draw this as in our notebook. Draw a table of values like that. And we know what the function is that we're working with. And we're going to substitute the values of those things into the function. So let's go ahead. Our function is y is equal to x cubed minus 5x squared. X cubed minus 5x squared. And it goes on to plus 6x plus 1. Plus 6x plus 1. And so in this particular question, you substitute the value there, like that. So basically what I did was I wrote down x values from -2 to 3, and we can talk about just the selection process there. But then here we write down y is equal to a specific polynomial. This is a polynomial with a leading coefficient of 1 and with the greatest power, of course, is 3. So keep in mind with these polynomials, they look like, in some ways, they look like roller coasters, right? Mathematicians help build roller coasters. Mathematicians pretty much do everything, right? And so if you know maths, there's nothing you can't do. And so this is one of those polynomials that is used to build like roller coasters type idea. And so when you build a roller coaster, or if you have a function that moves all over the place, it's going to look like something like that, where it's crossing the x-axis at specific locations. Each of these spots where it crosses the x-axis is called the root of the function. So when you think of the root, think of the x-intercept of that function. And so in this question, they're asking you about at what point does it cross, right? It says the function must have a root between which of the following values. which of the following values would be representative of it? You know, like would it have a root between -2 and -1, between 0 and -1, between 0 and 1, between 1 and 2, and between 2 and 3. So it's asking you, where does the root happen, right, in those values? So what I want you to do for me is go ahead and plug in these 5 values into the polynomial function. So when you plug in those 5 values, you're going to get specific y values, and we're going to use that to evaluate what the root is. So while you do that, I'm going to set up for the next question, and we'll go from there. So let's see. Excuse me? Okay, so I'm going to just write down some values here, but you guys can go ahead and simplify each one of them, putting in all the values, and then showing your work, which is very important for just the math note taking, right? Showing that work for every step that you're doing. So just so you know if you're right, I'm going to put this here. You can check your work and see if you don't get any one of these answers, then it just means there might be a glitch somewhere. And let's see. So, in the values they gave us, it started from -2 and -1, and they gave you all these values, and all their values were within the range of -2 to 3, which is why we've chosen those values from -2 to 3. So, okay, so go ahead and show your work to see how you can match each of these answers. And while you do that, as I said, I'll just go ahead and write down number 9, and then we'll discuss that after. And I'll write down number 10 as well. Okay, so I'm gonna pause and we'll look at how we're doing.